In this video, we're going to be looking at the properties of logarithms.
So let's look at the first property, and it's called the product property. So let's say you are going to be given log base b mn, that's called multiplication. What you're going to be doing is to simply break them apart and add them. Okay, why? Why are we going to do that? Because when you're going to multiply two powers, you add the exponent. So say for example, you have 2 raised to 6 multiplied by 2 raised to 2. That's going to give you 2, 6 plus 2, and of course that's going to give you 2 raised to 8. The second property is called the quotient property. So let's say you're going to be given log base b m divided by n. So we're going to subtract these logarithms. Okay. So why? Because when you divide two powers, you subtract the exponents. So let's say for example, 2 raised to 6 divided by 2 raised to 2, let's say. That's going to give you 2 raised to 6 minus 2, and that's going to give you 2 raised to 4. The third property that we're going to be looking at in this video is called the power property. So let's say you have log base b m raised to n. So what we're going to be doing is we're going to say n log base b. What did we do in here? Because when you raise a power to a power, you are going to multiply the exponents. So let's say for example, you are going to be given 2 raised to 6, and I'm going to raise it again to, let's say, 2. So what we are going to be doing in here is we are going to multiply the exponents, and that's going to give you 2 raised to 12. Use the properties of logarithms to expand the following. So in here we have seen logarithms of x, y, z. So it means to say that we're going to expand this one. So it's going to say logarithm of x plus the logarithm of y, and then plus the logarithm of z. Okay, so that's going to be your answer. Next, the logarithm of 2 times 3x minus 1. So if we're going to expand this one, it's going to be logarithm of 2 plus the logarithm of 3x minus 1. The third one is going to be logarithm base 2x over yz. So this is going to be subtraction. So it's going to say logarithm, don't forget the base, 2 of x minus the logarithm base 2 of yz. Okay, number 4, it's going to be the same approach. The logarithm of 5x minus the logarithms of 4y. Okay, so this is going to be log base 3, 81 raised to 2. So it's a power property, so we're going to put the power in here. So it's going to be 2 logarithms of base 3, 81. Now we can still simplify this one. So the logarithm of base 3, 81 is going to give you 2 times 4, okay? 4. That's going to give you 4. Where did I get 4? I simplified this one. Okay, because 3 raised to 4 is equal to 81. Therefore, log base 381 is equal to 4, and we're just going to multiply that, and this is going to give you 8. Okay, so another one in here. Log base 525 squared. So we're going to be putting the power in front again. 2 logarithms of base 5 raised to 25. Now we can simplify this further. 2 times, what is the logarithm of log 5 base 25? Now we know very well in here that 5 squared is equal to 25. Therefore, this is the logarithm of base 525 is going to give you 2. Okay, so we're going to multiply this by 2 again, and that's going to give you 4. So that's your final answer. Okay, so this time let's reverse the process. Okay, so earlier you were given a condensed one, and then you're going to expand it. This time you are given expanded form, and you're going to put it as a single term. Okay, so number one, let's say log base 5 4 plus log base 5 3. This is going to be a multiplication. If you're going to put them together, that's going to give you log base 5 4 times 3. So the final answer is going to be logarithm base of 5, and that's going to give you 12. Next, log 6 25 minus log 6 5. This is going to be a division. Okay, so that's going to give you log 6, then we're going to say 25 divided by 5. So the final answer here is going to be log base 6 is going to give you 5. So next, this is going to give you at least two operations. Log base 2 4 plus log base 2 2. This is going to be a multiplication, and this is going to be a division. Okay, so let's put them together. First, I'm going to do the multiplication. Logarithm of base 2 4 times 2, and then we're gonna divide that by the logarithm of base 2 and then 8. So simplifying further, that's gonna give you log base 2 8 divided by log base 2 8. Okay, you can still simplify this, but for the sake of this lesson, I'm not gonna simplify for now. So for the next, I think the format of this is on property of power to a power. So we're going to put that, simplify it first, log 7, and then we're going to x raised to 5 is equal to the logarithms of base 7 raised to 2. Okay. Okay, finally, number 5, we have the same again. This is going to be a power to a power property. So we're going to simplify that as logarithm of x squared and then minus the logarithm of y cubed. But if you're going to look at our answer, it's not yet finally uh, simplified because it is a subtraction operation. It means to say we're going to put it as a single term as division. So that's going to give you a final answer of logarithm of x squared over the logarithm of y cubed. So this is your final answer. Now let's look at the change of base formula. For any positive numbers m, b, and c with b not equal to 1 and c not equal to 1, log base b of m is equal to log base c of m divided by the log base c of b. Now, it might be very hard for you to understand, but let me give you a good example for you to understand what this means. Say, for example, we're going to be given the logarithm base 32 of 4 is equal to x. Now, let's see. Can you think of a number, let's say our base here, if we're going to put that into its exponential form, the base is going to be 32 to raised to an exponent, but it's going to equate to 4. Now, can you think of a number, a base number of 32 that when you're going to raise to a certain number x, it's going to give you 4? I believe there is none. This is where you're going to use your change of base of formula. Therefore, to solve this formula, so let's say this part, this one is going to be given as this. Okay, so let's rewrite that part. So it's gonna be, say, log of 32 and 4. So this is now going to be equal to our log cm here is going to be the log base of 2 4. Okay, I use base of 2 divided by the log base 2 of 32. Okay, so now I choose the base 2, okay, because of the 4. Now we can also use some other bases. We're gonna check it out later. So if you're going to be looking at this one, now they are on the base 2, it's now easier for us to simplify. Okay, log base 2 of 4, that's gonna give you 2, and log base 2 of 32 is going to give you 5. So the final answer is 2 over 5, or simply 0.4. Okay, so let's try to do the same problem, but we're going to change the base. Okay, so let's say we're going to put it in base 10, okay? So here, if I'm going to use the same problem, log 32 4, but this time I'm going to use the base of 10, log of base 10. I don't need to put 10 in there. That's going to be log 4, or the logarithms of 4 and logarithms of 32. If you're going to use your calculator, it's still going to give you 2 all over 5, or that's going to give you 0.4. So you see, the change of base is very powerful. In here, I use actually the base 10. Okay, the base 10 in here. Now let's try one more, the natural logarithms, ln. Okay, so I'm going to rewrite the same problem. That's going to give you the logarithms of base 32 and then 4. But this time I'm going to use natural logarithms, equal ln 4 over ln of 32. Okay, I would like you again to use your calculator, and this is going to give you the same answer like earlier when I used base of 2, base of 10, and now it's base of natural logarithms. They're all the same. So I would like you to understand that this change of base formula is actually very easy to understand. It's just that quite complex to really understand these very complicated things in here, but it's actually very easy. I hope you understand this lesson. Thank you so much.